Hello friends, welcome back to my channel. Now in today's video, we are going to look at how to fine-tune a pre-trained LLM model. Okay, so I'm not training an LLM model from scratch. I have a pre-trained model from Hugging Face, and that is trained on a giant copies of text data. That's usually scraped from the internet, and they train that to generate a base LLM model or a language engine. Now, I want to do a sentiment analysis using this LLM on some movie reviews. So I will take the base LLM that they've trained already. It's able to understand language, especially English in this case. I will take it and I will use some custom data set. In my case, it's my movie reviews database, which is the IMDb. I will use that to fine tune it so that it's able to predict based on my custom data. And that is going to generate a fine-tuned LLM model. I will take this fine-tuned LLM model, and as a user, I'll make queries to it and then look at the responses. If I put in a review of a movie that is not good, this LLM model should be able to predict that it's not good based on the understanding that it has gotten from this custom data set. In that case, the actual and the predicted are the same. And then we will measure the accuracy. How many times you get it right, how many times you get it wrong. Now, I would want us to interact with the model. And so I'll use Gradio to create a user interface so that we can load our model into the browser and interact with it. So stick around for the entire video. And now let's get into it. By the way, I'm a small channel and I'm trying to grow, so please like, comment, and subscribe to my channel for more videos like this. Now, let's get into it. I'm currently on my GitHub repository. And go to the repositories. By the way, all the projects I've done, I have them in repositories here, so follow the link in the description below to go to the repository. So in our current project, we have our fine-tuning LLM repository. I'm going to open that. And you can see the language is mainly Python. Now I've prepared all the code, the README and the requirements.txt you need to run this entire project in here. Okay. Right. So first, let's do a slide overview. We are trying to investigate how to fine-tune an LLM model on the custom data. Now the custom data we are using is data from IMDb, which is Internet Movie Database. And then we are going to use it to make some predictions based on some sentiment of people that watch movies. Now we will want to interact with the application via a UI. So for that, I'm going to use Gradio. You can also try on your own to use Streamlit as well. You could do that. But for this, I'm going to use Gradio to create an interactive UI. Now some requirements we need transformers. And that's going to come from Hugging Face. We need pytorch. The library for pytorch is called torch. And then, of course, we need our Gradio app. We need some other requirements like Python libraries or packages, but I will talk about that later. And then we will first need to set up our environment. And for that, we will create a virtual environment, install all the packages we need, and then we create a project structure. Now these, we will need them from the code we have here. And again, we will prepare the data. We'll do our model selection and fine tuning, model evaluation, and then we create our app and try to host it on our web browser. Now here are the requirements we need, the packages. We need pytorch, we need transformers, we need Gradio, datasets. Datasets is the package that has the IMDb data in there. We have evaluate. This will help us to evaluate our fine-tuned LLM model. And of course, we need scikit-learn. We are trying to do a classification model here. We are modeling sentiment analysis. So based on a movie you've seen, whether it was a good movie or not, we will take the comments that you make, and then this LLM should be able to tell whether that comment is a positive comment or a negative comment. So we need a classification model, and that's going to come from scikit-learn. We need accelerate. This accelerate here is used if you are running your LLM or machine learning model on a system that has a GPU on it. I'm currently on an Ubuntu system. Let's go to a Visual Studio Code here. By the way, I have the exact same codes cloned in my local repository here. When I do new fetch, see that I'm currently on Ubuntu 24 system. I have a GPU, which is RTS 4070 Super. So I have enough resources, but most importantly, I have a GPU, which is why when I go back here, I need this accelerate. Accelerate package is able to distribute workloads of LLMs or machine learning models across GPUs. Even though I have only one GPU, but it kind of makes it more efficient. Of course, we are going to deal with numbers, so we need NumPy. And then for Seaborn and Matplotlib, these are going to help us to generate plots, confusion matrix, and stuff like that. Now for our code, we will first prepare the data using this code, prepare data.py inside the source directory. And then we will use that prepared data that we have to train the model. We use the model we've trained to evaluate based on some test data. And then we will take the model that we've trained and the testing, if it's good, we will package it using our app.py, which is the Gradio app. So let's start setting up our environment. Now first, I will create a Python virtual environment and want everything I'm doing here to be isolated from the Python on my Ubuntu system. So I'll create a Python virtual environment with this command. Now this will create a Python VNV with this particular name. Currently, there's no directory here called VNV or LLM projects env. So when I press enter, that should create the virtual environment there. But after that, you have to activate it. So source, run that. Now what this command actually does is it goes in this directory, go to bin, and you see the activate functions here. This command will just run them or activate them. Press enter and you see that our environment is now active. Next, let's install our required packages. By the way, I've given you the reasons why we need all the packages in here. You can see here, the pytorch is deep learning package for GPU computations. Transformers, they provide a lot of pre-trained LLM models already that you can take and use for your own project. And then datasets has some standardized API datasets that you can use and can help you to process some datasets as well. Evaluate just helps us to evaluate any machine learning model performance. Scikit-learn, of course, is for non-deep learning tasks. It's a library for that. And accelerate distributes training of machine learning and LLM models across multiple GPUs. And then we use our Gradio to build an interface for our application. All right. First, let's install our packages or libraries. And everything is in the requirement.txt file. So we are installing basically all this. Press enter. Okay, so it's done installing all the requirements. Next, I'm going to create some directories. Already we have a directory called source or SRC. I'm going to create two more. One will have the data in it, and the other will contain our model once we train it. And that should create your directories there. Now first, let's look at how to prepare our data set. And for that, we have a script inside the SRC directory called prepare_data.py. This is right here. Prepare_data. This is it. I've prepared it in such a way that it's very easy to follow. I've added comments to almost every line of code or almost every block. Now, I did mention that we want to do a sentiment analysis of data sets on reviews of a movie. So I'm loading the IMDb. Now, this IMDb is present inside the datasets library or package for Python. So I'll use the load_dataset function inside that package to load it. So in the data, there are 50,000 reviews of movies on IMDb. And then I will shuffle it a little bit because if you check IMDb, usually the labels are structured such that the negative comments are in the first few rows before the positive comments follow. So if you don't shuffle it, if you train it, you will get 100% all the time for accuracy because it's going to be only zeros or only negative comments data that you will be training. So you need to shuffle it a little bit. And of course, once you shuffle it, you need to set a seed. You set a seed just to make sure that the shuffle that you made is kept consistent throughout the entire modeling. So once that is done, we go ahead and do a stratified balanced subset of each of the labels that we used, right? So we shuffled it, but we need equal amount of positive and negative reviews. In that way, we are not biased towards positive or negative labels. So that's what this function does here. We now have to put the labels side by side in a table. And that is why we call the concatenate dataset function. This will just put these two labels, label 0 and label 1, side by side in a single table. And we call that concatenate dataset also from the datasets library or package in Python right here. Now this specifies the amount of data points we are actually using. I'm using 2500 positive reviews and 2500 negative reviews. All together gives me a training data points of 5000. And then for the testing, I use 500 positive and 500 negative reviews. Together is 1000. So that's going to be my testing data set. Now after that, I will save these data points because I need them for training the model, which is in a different function. So I will save it inside data/train or data/test, which is why we created the directory data. So these data points will be in here. Okay. Now here is just a print function showing the length of each of the data points. And of course, this is going to return those data points. So based on our README, to execute the script, you use this command here. So press enter, and that should prepare your data set. Now you see that in the data, there should be some data points that should be in there. You see the test data set, this stuff. Then you have the train data set. And these are the results on your terminal. So we finished preparing our data set. It's time to train our model. So you use the script train_model.py. And that is the script here. It's the same thing on the GitHub repository. Again, I have comments inside the code so you can easily follow. Now, first, we need to import some libraries or some packages in here. We need OS. The OS will help us to write files or read files from our local machine. NumPy is for numerical computations. Dataset is where the data actually comes from. So we will use the function load from disk, and that will help us to load these training and testing data sets into our model. And then we will import transformers. Now these transformers are what's going to help us to load the pre-trained LLM model from Hugging Face. Inside that, we have auto tokenizer, auto model for sequence classification, training arguments, trainer, eval predictions, and stuff like that. Now talk about this as we go on. And then we need the package evaluate. This is going to help us to evaluate our model at the end of the day. Now first, we have a compute metrics function here. This is a function. And what it does is it's going to be used by the model trainer during the evaluation step to get the accuracy and the F1 score. These two are metrics for determining how well our model is performing. What we do here is from the evaluate package that you see here, using the load function to load the accuracy and F1 score. We would load the logits and labels as well. I'll explain this later. And then we also need the argmax. Now, when you train a machine learning model or an LLM model, the outputs are in the form of logits. Now, these are data points that are not or understandable in human form. So we will actually not use this for the prediction per se, but we will convert the logits into a readable form. And that is why we would need something like argmax. Argmax function here, which is a NumPy function, converts logits into class predictions. And in our case, positive or negative or zeros and ones. Okay. And then of course, this will get our accuracy score, and that is our F1 score. And this will return that. Now let's look at our training function. First, you can clearly see from here, we are using load from disk This is just going to look at our current working directory, go to data/train here, and load this data in there. And then do same for data/test. And we will save it as train_dataset and test_dataset. Next, we will load our tokenizer and our model. Now, I'm not training a whole LLM on my own. I'm taking an LLM model that has already been trained. So it's a pre-trained model. This is a smaller version of the BERT model. I'm sure you may have heard about this model, BERT. This is a popular LLM model on Hugging Face. And then I import a tokenizer. What a tokenizer does is it takes a sentence or a bunch of words and splits it into smaller pieces. Let's say something like this, saving the data set. It can split it as serve as one data point or as one token, ing as one token, there as a token, data as a token, set as a token. So it basically splits sentences or a string of characters into smaller chunks. So I'm using a pre-trained auto tokenizer. This is also coming from the transformer package right here. This is the tokenizer. So that will do that job for us. And then we will call our auto model for sequence classification. We have to specify the model we are trying to use, or the pre-trained model we are trying to use, which is right here, the DistillBERT based on case model. And you need to specify the number of labels. In our case, we are modeling sentiment analysis on movies, so it can either be positive or negative. So it's only two options, so our labels has to be 2. Now, this is the point where we actually tokenize the data. We are also going to pad the data after it's been tokenized. We want to pad it. If you take any string of text or characters and you put it in the form of a tensor is basically like a vector or a matrix. Usually, the dimension of the matrix may not be efficient for calculation, so we pad it by putting zeros around it, just so the dimension is efficient enough when we are trying to do our computations. Okay, so I just looked it up. Now, suppose this is your data set, and that's your input data set. But then, based on the kernel, or based on the computation you are doing, you expect an output of dimension, let's say 4x4, for instance, for this. But your input data is only 3x3. So in order for you to achieve the output that you're trying to look for, you can pad it with zeros, which is just putting zeros all around it in a dimension such that you get the correct output, and the output will be in the correct dimension that you're actually looking for. So that's the idea of padding. And some people call it zero padding. Let's go back to our code. So we will do that here. And then this is where we actually apply the tokenizer to both the training and the testing data set. Here are the training arguments. First, we need the output directory. Now, this is where the model will be stored on my local machine. So this will be stored inside the models directory, which is, let me close this. This is the models directory. So this sentiment classifier will be the name of our model and will be stored inside this directory here. Per device train batch size is 16. Now this is just a number of samples per GPU per step. And then we have the num train epochs. We set it as 3. This just means that our LLM model training will go through this data set 3 times just to get better. And then we have a weight decay of 1%. Now this is just a regularization parameter. If you know, in regression, there's a regularization parameter you can set, and this will help you to avoid overfitting your model. It's also very common in data science. And then we have a login step. By the way, this login directory is just a location to log our steps. Login step just tells us after how much data points should we log. So this is going to log every 10 steps. Now let's set up the trainer. And the trainer is what ties everything up together. It takes the model, the data, the configurations we've done here, and the evaluation, and pieces everything together. I'm calling this trainer function here. And inside the inputs, we need our model. We need some arguments, which are the training arguments I've specified here. We need the tokenized trained data, the tokenized texting data, and then we need to compute some metrics. After that, we can train our model using this trainer.train command. Once we've trained our model, we need to save it. We need to do some evaluation. So this is the path where we will save our model. Inside models, sentiment classifier / final. So inside this directory models, another directory we created called sentiment classifier, and inside that we'll have our model. And we will save the tokenizer as well, because we need both the tokenizer and the trained model for evaluation sake. That's why we are saving both of them. And then we can do some evaluation here by calling the trainer.evaluate. The evaluate is a package we imported right here. And this is going to also return the model path where we are saving the model itself. So let's train our model here. Go back to the README. To train it, use this command, Python, and then the file. If you're not inside the location, just give the full path. So look at this model. There's nothing in here currently. So when I run this, now the training may take a while. See that there are stuff already coming in sentiment classifier. That's the directory. Now at each rate, the machine learning model or the LLM is learning. Since it's learning, it's going to make some mistakes. So there's always going to be some loss function. And then there's a learning rate that's also happening. It gets better and better over time. I'll give it some time to finish training and I'll come back once it's ready. So it has successfully finished training our model. There are some results here. As you can see, there's accuracy, roughly 91%. This is the loss function, F1 score. Now we can also investigate. If you go to the models directory, you see sentiment classifier, and inside it, you see checkpoints 500, checkpoints 939, and then you see final. Now this is just the model readjusting itself. Remember, our epochs is 3. So it goes through it 3 times, and the last one becomes our final trained model, which is this right here. Now remember, we gave it a path. So this is exactly the path it's using to store the model. So everything inside the final constitutes our final trained model. Okay. So let's close this train model here. We are now on model evaluation. So I'll collapse this and go to evaluate_model.py. Again, I have all the comments in there, same as on the GitHub repository. Evaluate_model.py has everything. First, we need to import some libraries as usual. We are doing evaluation, so apart from loading the data from the disk or from our local machine, we need to load the model that we've trained so far and its auto tokenizer. After that, we just need packages for getting the confusion metrics, classification reports, and some plots. So the first function, we have a evaluate_model function. Now what this function would do, it would load the test data set. Remember, we stored this earlier inside the data_test. So it will load this data in here. Because remember, we are trying to evaluate the model. We train the model using the trained data. After training it, we don't use the trained data anymore unless we are training again. For evaluation, we use the test data. So it will load the test data only. And this is us calling the model that we trained. Remember, it's inside models, sentiment classifier / final. And this is our model. So we are calling that. Our tokenizer is also here. You see it right there. We also need to call the exact same tokenizer. That's also the reason why we set a seed earlier. That way, the training of the model and the tokenizer is maintained throughout the entire project. And then this is just a small code to automate how to run the model. Since my system has a GPU in it, this will select the GPU to run the model training. But if your computer does not have this GPU, it will just use the CPU to do that. And then this is a function that will tokenize the data set. So first, remember the tokenization I mentioned earlier? It converts the raw text into numeric formats, and that way the LLM model can understand, and then it will pad it and truncate it to a consistent length. And then we will return pytorch tensors. PyTorch is a deep learning library. Now, deep learning libraries like PyTorch and TensorFlow return tensors. A tensor is just either a scalar, a vector, or a matrix. So basically, any n by n dimensional object. And so you can see it right here. The return is a tensor to PT. And we are padding the maximum length, as I explained earlier with padding. All right. And it will take some example text because we're trying to evaluate it. So if we type in any review at all, this model should be able to predict based on it. This is just some space we are allocating in memory to store our predictions and labels. Next, we need to actually run our inference or do some prediction. And for that, we are creating a loop. First, I will call the model.eval, which just means set the model in evaluation mode, which is what this code actually does. And then we are doing torch.noGrad. Now, the noGrad just disables gradient calculation. We don't need gradient calculation, so this will just disable it. I'm disabling it because it helps to reduce the memory consumption when we are trying to train a model or evaluate a model. Okay. And then after that, we will process the test data set in batches of 32. We will first tokenize each batch, and then we will move the tensor data to either GPU or CPU, which is what we are doing here. Remember, we declared the device earlier, right here. That's the function for calling either GPU or CPU. And then we will get some model outputs. We're calling it outputs based on the inputs we give. And now we will use argmax. Now, because we are using tensors, when you tokenize data sets, the output is in the form of logits. We need to convert it into a readable format for our class prediction, and our readable format is zeros and ones. So this will convert the logits into readable formats. This is just going to save the predictions and the labels inside the open space that we declared over there. And then next, we need to generate some classification report. Our labels are 0 and 1, and 0 is for negative, 1 is for positive. So our coefficient matrix function would take the original label it came with and our predicted labels, and then we'll compare it to generate a coefficient matrix and classification report. And of course, here we will print both of them. And then I'll plot the coefficient matrix, or saving it actually as an image. See coefficient_matrix.png. We save it as an image, but the matrix will be stored as a blue heat map, and that's because CMap here is set as blues. Next, we want to show some prediction. Now, this is going to take at least 10 test data sets, and then it will truncate it, and then it will show the true labels. That's the labels the data set actually came with, whether it's positive or negative. And then the prediction that we did, what label it actually tells us. That's what this is doing right here. We are just comparing the actual to the predicted. Next, we will print our code out nicely from the actual versus predicted with this function here. And then this is going to return the full list of predictions and the true labels. Sometimes this may be useful for further calculation or computation. And this here is just to be able to run this script on its own. All right, so I will clear the screen. And now back to the README. If you want to evaluate the model, you use this command here. Copy, paste it here, press enter. Okay, so you see there. And so that is our coefficient matrix. This is our classification report, precision, accuracy, F1 score, and stuff like that. And these are examples that we did. Yeah, here we preloaded some sample examples for the model to look at. So this movie was so frustrating. Everything seemed energetic, and I was totally prepared to have a good dot dot dot. Now, the prediction that we made was true because the sentiment is negative and we also predicted negative. So that's a good prediction. And there are some more. You said these days, writers, directors, and producers are relying more and more on surprise endings. Dot dot dot. So it was negative and we also predicted negative, which is a good prediction. And of course, there are some more. We also saved our confusion matrix as an image, and you see it in the current location here. When I click it, this should open the confusion matrix there. There it is. So for the negative actual, we predicted negative as well, about 444 times. So these are correct negative predictions, and these are correct positive predictions. And these are the incorrect predictions that we made, where it was negative but we predicted positive. This was positive but we predicted negative. So overall, you see that the correct predictions are more compared to the bad predictions, which is why we had about 91% accuracy rate. Now you see that the graph had shades of blue, which is why in our evaluate model function, you see the CMAP is set as blues. So you use a heat map blue. All right, so now we've gone through the preparation of the data, training of the model, and we've seen some evaluation of the model. Next, we are going to look at how to package our model using Gradio so that we can get a UI to interact with it. These are nice because on your terminal it's pretty cool, but we want to be able to interact with it on a web app. Okay, so this should be our next stage. So in order to write our Gradio app, first let's clear the screen. Our Gradio app is inside the app.py file. We are just going to load the trained model that we created, which is inside this location. Because we are loading a model, we also need to load the tokenizer that we used, which is why we need the transformers package in here, as well as pytorch. And we are packaging with Gradio, so we need that package as well. Next, we still want to be able to use a GPU if it's available. If not, we will go with a CPU. And so we will make some prediction on our UI. First, we have a function here called predict sentiment. Now, what this function does is it's going to take some input tokenizer. It will return tens of data points. It will pad it. It will truncate it. And it will set the length as 512 as the maximum length. And it's going to take some text, something like our input, which is a text input right there. In the second line, this is just going to move the inputs to the same device as our model. Next, we are going to make some prediction. Again, in the past, we predicted using the evaluate model here. And we saw the results on the terminal. I cleared it, but we did see some results there. We want to be able to predict on our UI as well. So that's why we need this function again. And again, we don't want to use the gradients in order to optimize memory usage. So we make predictions using some inputs. When we do that, we will get logits, which are raw scores, not very informative. So we need to convert it. Now, in our case here, we want to convert it to probabilities. Probabilities makes more sense. And for that, we will have to use the softmax function. Remember earlier, if you want to convert raw scores or logit scores into zeros and ones, which is for a binary classification, we use the argmax. When you want to convert the logit scores or the raw scores into probabilities, we use the function softmax. And then we will get the index with the highest probability. So our binary classes are zeros and ones, or the negatives and positives. Which one has the highest probability? And of course, to get the highest probability, we still need to convert the logits into zeros and ones before we can actually count it. So we need the argmax function also there. And that's what this function is doing right here. Okay. And then we get a confidence score in the form of a list of type float. And the confidence score is just probabilities. in a list form. Next, we will return a dictionary showing confidence scores for both classes. Okay. Next is where we actually put in our Gradio app interface together. So first, create gr.interface. That's where the Gradio starts. Now this interface has some input. Everything inside this parenthesis here is an input. So it has some function which is predict underscore sentiment. So it's calling a prediction function here. And then it will take some input, the number of lines set, and has a placeholder for you to type in some movie review, right? And then it has some output. The output has two classes. It's going to be either positive or negative. This is the title of our application. This is a description of our application inside the UI. And these are preloaded examples that we can use to evaluate the model. And so when you run Python app.py, this should launch our Gradio app. Now Gradio runs on the default port 7860. So you need to note that as well. So in the README, let's get the command here. Again, the app.py is inside the source or the src directory. Paste this command here, press enter, and it started running our application in this location here. So copy this. By the way, the IP address 127.0.0.1 is the local host. So you can also use localhost. If I paste this here and go, this is our application. All right. These are the three examples that are preloaded. Remember, these are the examples here, preloaded in our app, and all these stuff are what you see on this page. So if I click this, it will automatically load it inside this location here. And now when I submit it, it's going to do the prediction. This is the input, that is the output. So submit. So this is positive, and we predicted positive. So that's like 100%. We can retrain the model with even more data by, in case we get some prediction wrong, flagging it. Okay, let's see. I'm going to use a different example here. Submit. This is negative, and we got it right. Also, that's fine. It was okay. Some parts were good, but others were quite boring. Submit. Now you see that this did not completely predict negative. It's only 99% negative because it says some parts were good, but others were boring. So, but for the most part, it predicted that it was not that good. So you can type any review you may have in here. I'm going to type something in, something random. It was not a good movie, but I was on the edge of my seat the whole time. Submit, and this predicts it as negative. Okay, I'm gonna just add something. My friends enjoyed it very much. Submit. Okay, so it claims it's as positive. Even though I had a bad experience, my friends did have a good experience, so it's predicting this as positive. So this is not exactly true, which also explains why when we did train our model, our accuracy rate was 91%. Which is also why the confusion matrix here is not completely 100% everywhere. We get some things wrong. Sometimes it's negative and we predict positive. Sometimes it's positive and we predict negative. Not a lot of times, but it still affects our results. Okay. So this provides you a nice UI you can use. You can type in any comments, just access how well the model works. So my friends enjoyed it very much, but I did not. Submit, and you see it's positive 63%, negative 37%. This is more of a better prediction than the previous one. Now, if it's bad, flag it, and it's going to save it. It will add it to the data set, and you can use it to retrain it. So this is how you would take a pre-trained LLM model fine tune it for your own analysis, like we've done here using sentiment analysis. You can use it for a lot of projects, really. Lastly, let's do some cleanup here. In my terminal, just use Control-C to exit out of the terminal. So our app should go down now. Okay, it's down. And then we need to deactivate the virtual environment. So for that, just type deactivate. Once we are out, you can now delete the virtual environment. Okay, gonna copy this. To remove it, use rm. Rm is the remove for bash. Now this is a directory, so use rf. This will remove the directory recursively. An LLM project environment was the name of our environment there. Here, press enter, and that should get rid of this directory, LLM project env. I'll end it here. Please like, comment, subscribe to our channel for more videos like this, and let me know in the comment section if you are interested in more LLM projects. Leave your comment in the comment section below, and I'll see you on the next one.